Hello and welcome to day 3 of Algebra Boot Camp, where we're going to be talking about solving systems of equations. We're going to start off by solving the systems graphically. So we're going to graph two linear equations and see where they intersect. So I'm going to start with letter A here. And if I notice it's already in slope-intercept form, so all I need to do is find the y-intercept. In this case it's 4, so I go up 1, 2, 3, 4, make a point. And my slope is -2, which is the same thing as saying -2 over 1. So if I go down 2 over 1, down 2 over 1, I'm going to make a line, take my ruler, and draw in that line. Then I'm going to go to my second equation, y equals 1x minus 2. So my y-intercept is -2, and I have a slope of 1. So up 1 over 1, up 1 over 1. And now I'm going to make that line. And then I find where the two lines intersect. In this case, they intersect at the point, 2, 0. So my solution is going to be 2, 0. So you should write your answer here as an ordered pair. If we look at the next example, again, I have slope-intercept form for both of these. And my first one has a y-intercept of +3. So I go up 1, 2, 3. And make a point, and a slope of 1. So up 1 over 1, up 1 over 1. Go ahead and draw in that line. Now, the next one, since there's no number added or subtracted from my x value, that means I have a y-intercept of 0. It's like saying +0. So I'm going to put a point there, and my slope is -1/2. Negative means I go down 1, and then over 2, down 1, and over 2. And again, I'm going to take my ruler and put that in like that, and I'm going to draw in my line. So again, I find the point of intersection. In this case, it's at -2, 1, and that's going to be my solution to the system of equations. Now, let's take a look at solving them algebraically. There's 3 different methods we use to solve algebraically. There's the equal values method, the substitution method, and then the elimination method. I'm going to show you one example of each one in this video. So the first one I'm going to show you is the equal values method. Anytime you have y equals and y equals, you can take and set the other side equal to each other. So basically what I'm doing is I'm taking this x plus 1 and replacing y because it's equal to y. So it'll look like this. X plus 1 equals 3x plus 5. Now we solve the equation how we would solve any other equation. So I start by subtracting x from both sides, and I get 1 is equal to 2x plus 5. Then I'm going to subtract 5. And I get -4 is equal to 2x. Then I have to divide by 2, and I get that x is equal to a -2. Now, we're not done yet because I have to go back and find y. So I'm going to substitute -2 in place of x in one of these two equations, it doesn't matter which one, and then solve for y. So I'll choose this equation here. So I'll take y equals -2 plus 1. Well, -2 plus 1 is -1, so y equals -1. Now, whenever you have your x and your y, I always want you to write the answer as an ordered pair. So that would be -2, -1. Because remember, the x value always goes first, and the y value always goes second. Now, a quick note here. When we solve systems of equations, what that means is if I put a -2 in for x, my answer is going to be -1 here, and if I put a -2 in for x here, my answer for y is going to be -1. So it's a solution to both of those equations. The next method we're going to use is substitution. When we use substitution, that means you take what this is equal to, in other words, y is equal to x plus 3, and I substitute that in for y in the other equation. So it'll look something like this. 3x plus 2. Now, instead of y, I'm going to put in x plus 3. and then equals 26. So the only thing different from here and here is instead of y, I put in x plus 3. Now again, I solve it like I would any other equation. So the first thing I'm going to have to do is distribute this 2 to x and 2 to 3. So that'd be 2x plus 6 is equal to 26. Combine my like terms, 5x plus 6 equals 26. Subtract 6 from both sides, I get 5x equals 20, divide by 5, and I get that x is equal to 4. So again, once I find x, I need to find y. So I'm going to take and substitute it into this equation. So that'll be y equals 4 plus 3, so y equals 7. So the solution to this system of equations is 4, 7. And in the last one, we're going to use the elimination method. I'm going to actually show you letter B in the elimination method. In the elimination method, what you want to do is try and get one of your variables to cancel out. In this case, 9 and negative 3 won't cancel out. 12 and negative 2 don't cancel out. So what I have to do is I have to multiply this bottom equation by something to get either the x's or the y's to cancel out. In this case, I'm going to get the x's to cancel out. To do that, I need to make this negative 3 a negative 9. So if I multiply the entire equation by 3, that will give me a negative 9x, so my x's will cancel out. I still have to multiply 3 by everything else. So since this is plus a negative 2y, that's the same thing as saying minus 2y, so 3 times negative 2 is going to be negative 6y, and 3 times 7 is going to be 21. Now, once I'm done with that, I no longer need this equation here, and I just combine these two equations. So 9 and negative 9 is 0, so my x's cancel out. 12y minus 6y is 6y, and negative 33y plus 21y gives me a negative 12. I'm sorry, there's no y's in there, just negative 12. So then I divide by 6, and y equals negative 2. Now that I have y, I need to substitute that back in to find x. I'll just take my first equation here, and that's going to look like this. 9x plus 12 times negative 2 is equal to negative 33. So combining my like terms, I have 9x, and I have 12 times a negative 2 is minus 24 equals negative 33. Add 24 to both sides, and I get that 9x is equal to negative 9. Divide by 9, and you get x is equal to a negative 1. So the solution to this one is negative 1, negative 2.